Hey everyone, welcome back to Skip Uni. Let's just jump right into things today. In this lecture, we're going to learn constructors in C++. I'll explain what a constructor is in C++, why constructors are used in object-oriented programming, and how to create default constructors and parameterized constructors with easy examples. If you're learning C++ programming for beginners or OOP in C++, this lecture is for you.
So here is our roadmap for today's explainer. We'll start with an introduction to constructors, compare manual versus automatic initialization, run through the 4 rules of constructors, check out a code example to see the real difference, and then wrap things up with a conclusion and next steps.
Let's kick things off with Section 1, Introduction to Constructors. This is one of those concepts that's practically guaranteed to show up on your exams, or when you're sitting across from a hiring manager in a technical interview.
To really wrap our heads around this, think about how a class is basically just a blueprint. It's like a map of a house, right? You can't actually live in a blueprint. An object, on the other hand, is the actual entity. It's the physical brick-and-mortar house that gets built from that plan. And when you build that real house, you usually need to set things up right away. You need to initialize it the very moment it's created.
And that leads us to the formal definition. A constructor is a special function of a class that automatically gets called when an object is created. I definitely recommend mentally noting that down. It is a special function, but the absolute most important word in that entire sentence is automatically.
All right, let's move right into Section 2, manual versus automatic initialization. Why do we even need a special function to do things automatically?
Well, to be honest, standard functions are kind of lazy. When we just write a function inside a class, it just sits there. It's merely a definition waiting around. To make a normal function work, we have to manually call or invoke it to wake it up. If you don't explicitly poke that function and tell it to run, it's just going to stay asleep forever.
So the big question is this: what if we want our objects initialized automatically the very moment they are created? We definitely don't want to rely on the programmer having to remember to manually wake up a setup function every single time they make a new object. That is exactly where constructors swoop in as our automated solution.
Which naturally brings us to Section 3, the 4 rules of constructors. If you're prepping for interviews, you really want to pay attention here. Interviewers absolutely love grilling people on the properties of constructors. This right here is pure interview gold.
I'm actually going to slow down my pacing here because you really need to lock these 4 rules in. Rule number 1, same name. The constructor has to have the exact same name as the class it belongs to. No exceptions. Rule number 2, no return type. A constructor doesn't return any value whatsoever. You don't even write void in front of it. Literally nothing is returned. Rule number 3, automatic invocation. You never have to manually call a constructor. It runs entirely on its own, the exact second you create an object. And finally, rule number 4, must be public. Your constructor should always be defined under the public access specifier. It cannot be private or protected.
Okay, let's pick the energy back up for Section 4, code example, the difference. Knowing the rules is great, but seeing the actual C++ code breakdown is the best way to prove just how much better this automation really is.
Let's walk through the without constructor approach first. Imagine we have a student class with a private roll number. In our main function, we create our object by typing student S1. But wait, the student doesn't have a roll number yet. We have to manually and honestly kind of clunkily invoke a separate function by typing s1.setRollNumber1001. We built the object, and then we had to separately wake up a function just to set its data. It's a totally manual 2-step chore.
Now look over at the withConstructor method. Because we defined a public constructor that shares the exact same name as our student class, our main function becomes incredibly simple. We just type student S1 1001, and boom, that's it. The instant the object S1 is created, the constructor is automatically invoked. The roll number is immediately set to 1001 without us ever having to write a second line of code.
And that seamlessly takes us to our final section, conclusion and next steps.
By completely getting rid of the need to manually call initialization functions, constructors make our code so much cleaner and far more automated. Before we wrap up this explainer, I want to leave you with a question to chew on. What are default, parameterized, and copy constructors? We saw a tiny glimpse of passing a parameter today, but there is an entire world of constructor variations out there to explore. Make sure you've got today's rules noted down, and definitely join us in the next explainer, where we'll dive deep into those different types. Thanks so much for learning with Skip Uni today, and I'll see you next time.